Well, good afternoon, everyone. Today we have a talk which will be given by two people. Felipe Criado, who is in front of me. He's an archaeologist, professor de investigación of the CSIC since 2000. He's director of the Institute of Heritage Science of the CSIC based in Santiago de Compostela. He has devoted himself to research on landscape archaeology. His essential research problem has been the concept of space, how each culture has constructed his own concept of space adapted to its way of life and relationships, and relationship with the world, and how in this way, the concept and experience of space has been changing. This led him to the concern with the symbolic and cognitive issues, and later to the Synergy Grant project they are going to talk about today. More generally, he is interested in interdisciplinary approach to research, and particular how to incorporate the human social sciences into big issues and research priorities of other sciences. He has written 25 books, more than 150 papers. He had a bachelor degree from the Universidad de Santiago de Compostela, and he also spent some time in Cambridge at that time. What else? He was president of the European Association of Archaeologists in 2015 to 2021, and he was a coordinator of the Human and Social Science area of the CSIC since 2004 to 2009, and National Research Award in 2023. So last year he received the National Research Award. The second speaker is Luis Martinez, to whom I know from a long time ago. He's director of the Human Cognitive Program and the Visual Analogies Laboratory at the Institute of Neuroscience in Alicante. Previously, he was trained at Rockefeller University in New York under the direction of Thorsten Wiesel, who was Nobel Prize in Medicine and Physiology in 1981. In his work, he uses a markedly interdisciplinary approach, including cognitive and computational neuroscience, archaeology, philosophy, social science, magic, and art. His main interest is to understand how memory, reasoning, intuition, and social context condition our behavior and perception of reality. He is the author of numerous scientific articles, essays, and opinion columns, as well as co-author of 2 books with Jordi Camí on neuroscience and human cognition, including The Illusionist Brain, printed in Princeton University Press. His work is funded by the most prestigious international institutions, such as the European Research Council and the Human Frontier Science Project Organization, and has been featured in numerous media, including several television documentaries, both in Spanish, in Spain, and abroad. So Felipe and Luis, thank you very much for being here.
And thank you so much. You become finally interested, there could be even some pieces of research, perhaps, for some of you. Okay, this is the topic that we are going to develop this afternoon. As Luis and I used to do, we will talk all the time each other and exchanging part, or even at some point, perhaps, contributed together to the question. The title we chose was that one. However, the research we are going to present is all about what is our Escape projects. XScape is the acronym of the project. Perhaps it won't be too much interested for this sort of audience to come to the idea of why this acronym, what XScape means. It's much more interesting to realize that the short title is Material Minds, in what gives us a very good idea that we are looking for the material foundations of the minds, and to look and to study how actually what we understand as mind, it cannot be explained out of any relations with the material worlds. And this is actually what explains that one neuroscientist and one archaeologist as such came together many years ago to start thinking and considering what to do. And the final result of this collaboration that we started already in 2013 drove us to the Synergy Grant project. To start, we can come through some examples of visual illusions that perhaps are familiar to all of you. I don't know if you know this one, but the question is what of both lines is longer. Most of the people, it's interesting, did you realize? No. Looking at that screen, they are equal, but looking at this, one looks longer than the other. I guess that most of you, will say that this is the longer one. But in fact, if you can see, actually they are the same size. Well, this is another way of presenting the illusion. Yeah, Luis, we must study that because the aspect ratio of the screen is changed and then totally changed the way to understand the illusion. You could see. Look at this. Yeah, sorry. No, because you're getting that, not this, I think. Okay. Well, let's follow. Well, still, some other examples too. Well, one of the things we are doing in the project is to present these kinds of illusions to many people from many different cultures, including indigenous communities in places as Africa or different parts of Southern America. Most of these people usually look at them and see exactly the same sort of illusion of way of looking that we apply to that. For instance, coming back to this illusion, if you don't know it, the question is, they are the same photo. It's just repeated, one placed beside the other. And the question is that when these photos are placed together, this photo of Pisa Towers looks much more sloppy than this one. But actually, they are exactly the same. You can just realize by hiding with your hands one of the photos. Or again, for instance, this one. What of these two pieces is bigger? Again, by the way, they are same size, but the one on bottom looks bigger than the other. When we perform this sort of experiments with people around, including indigenous communities in different countries in South America or other places, most of them look exactly the same sort of answer or the same sort of illusion we saw. But this is not so obvious sometimes. For instance, look at that now, this other illusion. The question here, look at this. Look at the main screen. Yes, definitely we will have it to study. Yes, aspiration too. The question here again is, what of these two faces, what again are the same photo, looks bigger, looks fatter? What would you say? The right one. Well, this is actually what perhaps 95% or 97% of people in our sort of environments always will say. But first time I have the opportunity to perform, to present this image to Con people, what is an ethnic indigenous group from northern Argentina in Chaco, they said to me, no, this one. And all the group there were agree that this was the one fatter. I asked, quite surprisingly, I asked them why, and they gave me one answer. The real matter was that a few days later, I took the opportunity to again present this image to Guarani people in other parts of Argentina. And 2 months later, we have again the opportunity, at that point, Luis and I were together, to present this image to other indigenous people in Paraguay. And in all these cases, again, they say this. What was quite surprising, but what was much more surprising to realize that the answer, the explanations they gave to explain why the fatter was this was always the same. And the explanation was so simple as this. They say, well, because this is like a bag. If you turn it round, everything goes down. So if you put the face that way, then all the fat, all the bloody of the body liquids and so on will go down. Then logically, this is fatter. This is explanation that would be, and then you will start to figure out or to understand why to bring expertise from the field of social and human science into this research makes something. Because if you just hear this answer, you will say, well, okay, and nothing else. But if you have the opportunity to have a study from an anthropological point of view, this group of people studying their worldview, their cosmology, their ideas about the world, about reality, about the society itself, you will know that for all these societies, the human body is like a bag, it's a container. It's understood, our body is always understood as a container, as a plastic bag. This is the reason what explains that the body many times is compared to pottery, to bakery, and to other different kinds of containers. And exactly when you have this idea of body as a container, is totally true that if you turn around the bottle, all the liquid in the bottle goes down. So this is just a very simple way to understand, to present one of the things that we are trying to explain, that are all these, oh, sorry, I forgot that, so you can see. The question then is, all these illusions works universally. We, Western people, Western researchers, most of the times realize that everything will look usual must be universal. But actually everything is the result of history, is the result of deep and complex social processes that have happening in totally different ways when you look to different societies or to different chronologies in history. So history, society, human behavior has something to do, or has something to say about the universality of this illusion. This is a research problem to explore. The matter is that if we try to explain why these illusions work together, it's quite simple to answer that it could be because the common biological basis of humanity, what is completely out of questions. It could be also that it is because the social context, for instance, things like education, social training, social experience. It could be also because people embedded in one society share the same language and then share the same linguistic models, the same grammar, the same vocabulary, and so on. These are ideas or proposals that have been made many times when trying to explain the universality of phenomena. But what we try to add to this set of presentations is what is the role of material immersion, material embedment, in particular in material context. For us, this is a really important matter, and this is also what is all the project about, because at the end, what we are trying to avoid is to restrict ourselves to what has been characterized by this author as just white people who is Western educated, becoming from industrialized countries, who more or less are rich or average class, and embedded also in democratic countries. Most of our analysis and experiments in neuroscience and cognitive science are performed with this sort of people. It's completely exceptional to find, as Enrique and your group has done, to perform experiments with other different people. And this is exactly what we are trying to do. For this, well, sorry, at that point I must also beg your pardon, because just a few minutes before the presentation, the English version of the presentation was corrupted and is not running anymore. So we have to come back to a previous version of the presentation in Spanish, or part of the slides in the presentation are in Spanish. Well, to answer this and these sort of things, we conceived together the X-scale projects on material minds. We are 4 PIs leading the project. Beside Luis and I is also Johannes Müller, who is archaeologist in Kiel University in Germany, and is also Andy Clark, the British cognitive scientist and cognitive philosopher, who is also engaged, I would say very engaged with the project. The research question of the project is very simple. It's even simple in English than in Spanish. Is do the worlds we build alter our mind? That means how everything that humans do, including not only buildings and cities, but also including different forms of land use, different forms of landscapes, different forms of materials and objects to make things, how all this material world we build actually interact with our mind and with our cognitive process. To answer these questions, we decided to combine, I will go quickly through this, to combine, first of all, different sort of disciplines, and neuroscience and cognitive science go hand by hand with archaeology, anthropology, history, and other different disciplines. And we also decided to perform studies and experiments that are related to many different sort of historical anthropological cultures, that means from different continents, from different sort of societies. And at some points, by the way, about the end of the project, we will check some of our preliminary conclusions also coming to studies with big apes, to actually try to realize whether the main hypothesis we finally could find are something that just restrict to humans, or perhaps are even at some points beyond humans. But the most of the project is concentrated in human action, in human activities, in human projects. The amount of case studies we are performing already is quite huge. We are working, well, not yet, but already we are working many of these case studies that distribute all about around the world. Well, I think that I could, well, some questions also to start about our ongoing studies are firstly concentrating with pottery, with ceramics. You will ask immediately, why pottery? Why pottery? The reason is that pottery is a sort of material that is very common. It has been very common for the last 10,000 years and characterized very well totally different sort of societies. We find pottery that belongs to very simple, basic groups that almost don't practice agriculture, for instance. And finally, we find pottery that belongs to much more complicated social entities as states, ranking societies, and things like that. Besides that, as I said, pottery is very frequent study, and we archaeologists know very well, know a lot about pottery. Actually, we can say that almost every culture is characterized by one or some or a few group styles of pottery. At some point in the past, still in some of our society works, the idea that show me what kind of pottery you use, and I will tell you what group you belong. Because pottery styles were also an indicator of social belonging, of social identity, and so on. So pottery is a very good material sample to study. And this is the reason because we are devoting a lot of work to perform experiments about pottery. But pottery is not the only one, the only case of materiality that we are studying. Art, prehistoric art will be also very important. And beside that, at some points, we will come to other sorts of materialities, including jewelry, body decoration, but also houses, or even reconstructions of old landscapes and so on. Beyond that, at some point, we are also going to work with indigenous communities. And in that case, what we try to do is two things that are pretty obvious. First of all, having the opportunity to work with people who is trained, educated, embedded in completely different social conditions, we are going to repeat the sort of experiments we are doing in other places, as Germany or Spain. Obviously, what we are looking is to what extent the response, the perceptual behavior that these people have to the same experiments we have done here is still comparable, or is not at all, with the results that we are finding here. Do they react to a specific pottery style in the same way we do? This is the basic question. Beyond that, of course, going to study with these people also give us the opportunity to study their own materiality and bring back with us also this stimulus to see how our people, how Galician people or Balearic people react to these materialities. Well, quickly, for doing that, we are applying a set of techniques and methods that has to do mainly with eye tracking, but also with biometric measurements, and also EEG. Besides that, let me quickly come. Well, the main research facility for the CDRT grant project is based in our institute in Santiago de Compostela. It's called already the Material Minds Lab. Emilio, I think you have the opportunity to also visit the laboratory when you were there. Well, the Material Minds Lab is a facility where we have the most basic or the most important experimental capacity for performing the experiments. Again, well, this is just to say, but I don't think it is necessary to explain much more about EEG, biometrics, measurements. But let me quickly come to this. Something that we are also developing is our techniques to study motion tracking, to study in motion, in fact. That means to extend the study of the perceptual process not only to the motion of our eyes, but also to the motion of our fingers, our hands, our bodies, or even to the human movement around. Because let's come to, this is an example, perhaps Luis would want to select us to you.
It works, right? This is a, just one back. What you see here is a pilot study that we did to set up the technique and see how efficiently we could track movements even to the finest of the details. We can follow all the finger parts and so on and so forth. And then how we can train the machine learning algorithm to do things for us. And now it can automatically label all interesting or referential parts for us in the video without us exactly having to mark them or to teach the algorithm. For instance, Miguel Angel here is doing a French drop, which is a very simple trick to disappear a coin by pretending it to pass the coin from one hand to the other. I'm not doing it. Actually, the coin is always here. And here the machine learning algorithm is trying to follow the coin and see if you can trick the algorithm as you trick a human, and it works perfectly fine. It gives you probabilities of where the coin is, actually. Sometimes it correctly assumes that he hasn't passed the coin. Sometimes he's fooled as well. But that is simply to show how precisely we can do that, and we can do it with bots also, rather than only looking at what people look at. We can see how people manipulate the stuff. And this is an archaeologist who's becoming blind. He's almost totally blind by now. And he knows this pottery very well. And he's reproducing with his hands, or allegedly, what his eye movements should have been in order to explore the same pot. Right? So we can do all these type of things also.
But we can do it even. You are going to prosecute us for destroying institutes, equipment. Well, we are even looking at the possibility to employ these techniques to study the movement of people around in an open landscape like this. These are not just rocks, are rocks with samples, very good examples of very old rock art, primitive, prehistoric art. So actually the movement of the people when coming up to these rocks is also in some way driven by the presence of the rock art. And moreover, because rock art differs every time, it was the one way 7,000 years ago, and 1,000 years later, it was with a total different way. Each rock art has also different ways of being seen. But being seen on this case, because we are talking about big objects, implies different moving in relation to the rock art. So this is one of the reasons because we are actually expecting a lot of motion tracking
in this case,
studies.
Yeah, Felipe, let me jump in
yes,
for one thing, just one thing. In this case, most of the subjects will also be wearing an eye tracking, mobile eye tracker. And our idea is to do that in order to find a continuum between body movements and eye movements when exploring something. It's like the idea that all eye movements, from the very minute fixation eye movements to the large saccades, they have the same dynamical properties. And they explore the visual scene roughly in a similar fashion. Our idea is that the body will follow the same laws and will be something similar, but that hasn't been proved yet. So it's an hypothesis that we are working on.
But still, and overall at this point of the project, is eye tracking what is the technique, what is much more informative. I don't know how much we need to come into details about eye tracking because, but.
And there's a reason for that. There was a reason for that. Is that roughly for jumping for the trying to justify the assumptions that we made in the project and why we use the techniques that we use and we are doing the things that we are doing. When Felipe and I first met, we suddenly realized that we're asking the same questions, but coming from totally different points of view. And he was trying to understand. He had very developed theories on what landscape transformation means and so on and so forth. But he wanted to investigate what are the cognitive bases of those transformations and didn't know how. And I was in my lab trying to study visual cognition, but realizing that whatever I do in the lab is not really ecological and not really meaningful for most of the things that we do on our daily life basis. And since I wanted to study things that are abstract at a high cognitive level, a reductionist approach always takes me longer from that place where I want to be and down to the basics. So the idea was to find a way of compensating for the drawbacks of each one of the techniques. For instance, you can be in the lab in a very reductionistic approach. You have a lot of control over the experimental variables, but your ecological relevance is minimal. Or you can be in an ecological setting doing a task that is normal in your daily life, but your control over variables is non-existent, essentially. So you have to approach those two things. You have to keep as much control as you can while you add ecological relevance. And eye tracking for that it was kind of an easy choice because that's something that you can perform in the lab with an equipment and take the same equipment even out of the lab and have somebody wear it while goes about on a daily basis. That is the reason for eye tracking, and many other reasons that I will get into in a while. So challenges and opportunities that we faced at the time. Well, I think that this is the first time that or audience that I won't have to explain this slide at all, which is the influence that bottlenecks have on processing information, right? So if you have a camera with a high resolution, then you incur in a cost that's sending the information to a processing stage or whatever. This is the same thing. With our eyes are very high resolution cameras, if you allow me the analogy. They have 105 megapixels each, but then if I want to send all that information to the brain, the information that they gather in the retina to the brain, I would need an optic nerve of 105 million cables, which is impossible to assume biologically because it occupies roughly a third of my entire brain hemispheres. It also is extremely costly because I would need lateral geniculate nucleus, which is the nucleus in the brain that first receives this visual information, to grow accordingly to accommodate all that information. Then B1 would have to grow again to get the information from the DLG and so on and so forth in sequence. The entire brain should grow as much as a delivery track, roughly. So that is, and the energy consumption of that is unthinkable. So the same solution that is applied here, which is compression algorithms, is actually applied here. The difference is that here, the compression algorithms are so good that are essentially lossless. They lose very, very, very little information, particularly the new ones, the most new ones. Here, all our compression is lost. Whatever information you don't carry here, you lose it forever. Right? That's the thing. And the compression is huge. I mean, you are compressing information by 2 orders of magnitude. Rather than sending 100 million cables, send only 1 million cables. So in essence, your camera has 1 megapixel resolution, in essence, which means that this is the image of a character that your eye sends to the brain. You know the character, right? Most of you should know that this is Charles Chaplin. And you know that this is Charles Chaplin because Charles Chaplin is already in your head, to put it bluntly. If I had put here Felipe's picture or my picture, gone through the model of compression of the retina, you wouldn't know who the person was, even though we've been here for half an hour talking in front of him. But you know, because Charles Chaplin is already part of your internal model of the world. You accumulate a lot of information, it's in your memories, But in reality, then, whenever you look at something, you are not perceiving that thing. You are predicting that thing. You are predicting that the information that you are receiving is most likely caused by Charles Chaplin. But you don't see Charles Chaplin. And this is the conceptual framework of the project, which is active inference. To go quickly through active inference, because I don't think I have to explain it, it is based on your internal model that has different states. And the role of your internal model is to predict what causes the hidden states in the world, the sensations that you are receiving at any time. This loop is closed by action because through action, you change your predictions, you update sensations that update your internal states, and so on and so forth. So you are constantly interacting with the world, with the materiality out there. That's why changing the world likely changes your mind. And the coevolution between mind and work is at place constantly. And this is a very interesting point in time because we are about to see, or we are seeing already, experiencing many and dramatic changes in the way we interact, not only to each other, but with things as well, right? Active inference also predicts that the role of this loop is to minimize prediction errors, because that's what saves you in the world. I was working in Bayesian brain hypothesis when we all started this project. And we find out that essentially that's what the LGN does with the visual information coming out of the retina. I think that I can show you. This is just a short video in which you have a stimulus. This is a very realistic model of the connection from the retina to the LGN. I mean realistic because it's purely informed by experimental data. And what you have here, they will separate in a while, but you have here handwriting, which is in blue. You have the prediction that you make using the population responses of the retina as a whole, which is in magenta, I think. And you have the prediction that you make using the population responses of the LGN. And when they separate, you see that the retina, there are some parts that are hardly even readable, but in the LGN, it has corrected many of those mistakes already. As information flows bottom up, there's feedback top down that corrects those things. So again, predictive processing and active inference. That's it. Charles Chaplin. So second thing, we see pixels, that's for sure. But operationally, we don't work with pixels. Our image processing or image apparatus in the brain does not work with pixels. It actually creates multimodal representations of things. And as we will see, particularly representations of what we can do with things, right? Okay. And this is just to go fast. Information is processed coming from the eyes, go to the LDN, primary visual cortex, extracts low-level information from the image, usually contours, basic forms, until you get to inferotemporal cortex, fusiform gyros, and so on and so forth. And then this type of selectivity emerges selectivity to things that you have experienced at some point in your life, that you know, that form part of your internal model of the world. And these are not static representations, by the way, by no means. They are very plastic, they change every day, and so on and so forth. This is one example by the guy who discovered this type of behavior, who is Rodrigo Quiroga, now in Barcelona. And this is a cell that responded to Luke Skywalker, in this case. And it's multimodal, the representation. There's nothing visual about this response. It could respond to any picture of the actor, Mark Hamill, I believe it was. It could respond to the written name, to the spoken name by different voices even. It responded slightly less, but significantly to Yoda, which means that the correspondence is not 100%, but it overlaps with other concepts that are firmly related to it. right? But it does not respond to other actresses or actors or landmarks like the Tower of Pisa, whatever. It responds to that particular character and things that are closely related to that particular character. So the question that is usually asked, and one that I know Rodrigo gets a lot, is how do you learn a new concept? How that enters your internal model of the world? And here, there's an experiment which I love because it's so simple and so illustrative that is amazing. Here are drawings of neurons, nerve cells, in your brain, made by 3 different types or categories, or you wanna sort them, of people. One of them is biomedical students who had training neuroscience, I don't know, 2 months, or their experience is limited in neuroscience. Another is PhD students and postdoctoral students. And the other one is people like me with decades of experience working in neuroscience. They are arranged in rows, and each one of these groups draw on a row, okay? Are organized like that. So who do you think that draw each one of the rows? The students of biomedical students, which one? Do you think? The upper one. Okay, that's right. Biomedical students know very little about neuroscience. They, in words of Felipe, they have not tamed the concept yet. They didn't brought it home. It's not part of their internal model of the world. That's why all drawings are very similar. They are suspiciously similar to the drawing that appears in every textbook of neuroscience. And they even put names. You cannot see it because of the quality of it was in the original paper, the quality like this, but they put names in the different parts, just in case it's not clear, right? When you gain experience on something, then you start, one thing that is noticeable is you start to individualize the representation that each one of the subjects has of a neuron. It loses detail. It's kind of, it gets only what's relevant for me, for the way I work with a neuron. And it notes that the other parts I can skip them. I can live without them, okay? And the extreme is this case, right? Like here you have Claudio Milazzo here, that a neuron is simply a processing center with an input and an output, and that's it, right? And then you have an anatomist here. Shape is extremely relevant for that person. But they are all different because even though we share, and this is something that we can discuss, and we discuss many, we don't share our internal models fully. We don't fully share them. Of course, we have many, many commonalities because, I mean, we are the product of the evolution of our species. So we share many, many things, evolution of our species in this world, in this particular world. Most of us have been raised in cultural backgrounds that are very similar to each other. But then we have the singularities that depend on our own personal histories and that we don't share with anybody, not even with our closest ones, right? And these are the different peculiarities. Felipe's question is always the same when it comes to this topic is, okay, if the internal model is an individual creation, how come we all share the same world and the same internal model of the world when it comes to what is truly relevant, right? And this, it's tricky to answer that question. It's not so simple as what I just said. It's because we share evolutionary past, we share a culture. It's not as simple. And perhaps the response is materiality. So
at least one of the responses.
One of the responses.
Or part of the response, but
right.
Better to say.
Internal models of the world. You all see the rabbit, right? It's a supermarket bag, of course, plastic bag. But you all see a rabbit because what you are doing is you're not seeing the bag for what it is. You are looking at your internal model and trying to find what is closest to this. In my Wikipedia of concepts in my internal model, what could explain best this? And then you come to the rabbit. Oh, rabbit is much more interesting than a supermarket bag. This is not as easy, but it's exactly the same thing. You can force yourself at figuring out what this is. And I've been said a fisherman, I've been samurai sometimes. Yeah, people come up with very different interpretations, but they are all different because there's very little information here. The work that you have to do to find a match is harder. Do you know this illusion? Some of you might know, particularly those coming from psychology might know. You see a landscape, it's kind of a foggy landscape. Sometimes people say it's like, there's like a ship in the sea. I don't know. I never saw that one. All you struggle to find a match. All of you are right now struggling to find a match, and it's harder. It's not possible. It's a cow, the animal. Do you see it now? It was in disguise, of course. Yeah. Horns, ears, snout, ears. Do you see the cow now, right? You see it now? It's obvious, right? Because now the cow is already in your internal model of the world in this form. So you recognize it. You are predicting it now. You couldn't before because it wasn't there. We're trying to match all the time, right? And this is the relevance of interacting with things all the time. Of course, internal models come in more fashions. This is, what is this? It's a map of the world for a fish, right? So you only see oceans and the coastline. That's all a fish would see. Of course, it's not true, but it's fun. And we have maps, internal maps for everything. It's not a bizarre concept that we are making up or is coming out of nowhere. We do know that we have them for many things. This is the somatotypic map for an average person. And you see that there's no isomorphism between the map and the territory, which is also something coined by computer scientists that is very nice. There is not, because here, the size of the represented parts of the body has everything to do with the relevance, behavioral relevance of that part of the body, and not with the size in the real body. So, for instance, the hand, fingertips, mouth is very relevant for us, right? And they grow accordingly to the point that this would be the reconstruction of the homunculus of a person if you kept constant the sizes. These maps are not isomorphic with the world. They don't represent the physics of the world or the properties of the world. They represent the interactions that we can successfully establish in the world, and that we can deal with that. And that's why I said before that we don't see in pixels, even though we see pixels. Of course, we see in affordances. We see the things that we can do with things, with the stuff that is around us. This is Chema Madoff, a photographer that, as Claudio said, I don't see the same things. The things exactly the same as Chema Madoff, for sure. I mean, this is a manhole cover. But Chema Madoff, simply by putting the dishes right there in that position, it's almost impossible not to see as a dish dryer, something like that, even though it's a manhole cover, right? Affordances can be false, like in this one. This is a false affordance. No, I don't think anyone would dry the dishes there, to be honest. They can be hidden. They can be real. I mean, I know what's the affordance of these, right? The erase, I know perfectly what I can do with it, and so on and so forth. They can be hidden. For instance, this wheelbarrow, I mean, it's usually used simply to transport things, stuff. But at the end of the day, if you want to just have a beer and smoke something suspicious, then you suddenly find a new opportunity for action that it was hidden. It was never there. You just saw it when the context came, the right context, when the opportunity arose. So that also introduces the question of my affordances are the same as your affordances, and the question is no. And what would happen if, for instance, two people who had different views of the affordances of a wheelbarrow met for the first time, right? And they are, here's one guy walking, carrying a load, the other one saying, come on, do it this way, please. But if this guy doesn't know what a wheelbarrow is, that's what he would do. I mean, this is a stage, of course, but this is exactly what happens when two people look at something, one understands or knows affordances, and the other don't. I think I will fast forward through this. If there's a question later, I will answer it, but then it's a contextual machine or brain. It's contextual. That's why it's so important to really think through the things that we do in the lab and come out of the lab and try to do things outside of the lab. This has a long history, of course. There's nothing that we have invented. This is Daniel Kahneman. Is this a B or a number 13? Well, it depends on what's around, right? It's a number 13 or it could be a B. But if a picture is worth 1,000 words, then context is worth 1,000,000. That's what they say. But this has a long history, right? I mean, we all know that context matter because there are these illusions, there are luminance illusions in which the luminance of the central disk is always the same, but our perception is not. It's not because it's based on context. And in this case, the upper and lower part of this whatever it is, semi-cube or whatever, is exactly the same. I only have to hide the contextual part of the image, which is the separation between the two sides, and you see it exactly the same. This is the same for everything. These are faces. They are faces of very famous actors, and they are handsome. They are pretty. They are famous for that, in part. And but if you keep your eyes right at the center, and you don't move your eyes, something happens to the faces. You don't move your eyes. They seem kind of distorted, and it's because we don't interpret faces right for what they are. We interpret faces for the status they acquire in a series compared to what has happened before. So if I go from a face that has very thin features to one that has grosser features, then it becomes grotesque, purely grotesque. And the other way around, it's also true. And now the important stuff is eye movements. Why do we use eye movements? And I will skip fast. When we look at a picture, this was work by Jarbus. He was one of the first to be able to follow the eye movements using an apparatus specially designed to track the scanning movements that we perform when we look at a picture such as this one. And the funny thing is that because our retina has a specialized part for high resolution, which is the fovea, but it's a tiny part. It's only 2 degrees of visual angle. We don't see the picture in full quality, such as it's here. What we do is we make a fixation, perceive this in high quality, while all the other appears in a fog of very low resolution. And then we hypothesize what's in a different position. We move our eyes to confirm the hypothesis, and we keep scanning the picture constantly in this way, right? And we build an illusion of continuity, of that everything is perfect, simply because we are looking in our minds, not actually in the image that's before. This is getting long. You know this illusion? This is kind of classical as well. It's a grid that is perfectly organized in the center and disorganized in the periphery. If you look straight to one of these intersections right here, whichever you want, you'll see that something happens with the grid. You don't move your eyes from the center, something, it kind of heals. The actual title of the illusion is The Healing Grid, because you repair the grid, right? And that is precisely that. You only have good resolution at the center. The low resolution of the periphery is consistent with what you see in the center, and fill out all the information. Okay, so when you look at a picture like this, it can be scanned in many very different ways, depending on your contextual situation. It could be a question that is asked to you. It could be that you are thinking about something and your train of thought interacts with your vision. And it gives you very different scanning patterns. The dots are the fixations where you see at high resolution, and the lines are saccades which link those fixations and allow you to interact. So the funny thing is that different people looking at the same painting can have all these different scanning patterns, and you only see precisely where you fixate. Where you don't fixate, you just fill in the information there. Okay? So eye movements are very informative about many things. While reading, you don't fixate in all the words. You don't fixate on each one of the letters. Actually, you fixate very sparsely and on very stereotyped positions within letters. For instance, you tend to scan only the beginning or the end of the letter, preferentially, and you skip everything else. So reading is, in some way, more writing in your head, in your mind, than reading itself. You're completing the words, all the words. That's why you can do this very easily, right? You can read this text, and only the first and the one letter in each word is in order. All the other ones are scrambled, but you can read it because you preferentially fixate in the first and the last letter, and you predict the rest. You're making a prediction of what that word is. And that very same thing you can do when reading an artifact, a pot. Here is explicit what the information that you're getting, how you're reading. Here is implicit, but still you're reading the information here. Okay? And Felipe, I think that we'll skip this part and follow you end up. One more thing about eye movements. Another thing that eye movements do to you, which is something that we're exploring, this is the visual exploration of a subject while looking at this particular pot. It's reading the pot, actually. And what we realize is that when you do that, I only want you to look at this, actually. This is the entropy of the scanning eye movements. And what you see, this is 6 seconds total time, but here what you have are the successive fixations. It's not time, they are fixations, but the total time here represented is 6 seconds. These are consecutive fixations, which is that entropy goes up until it flattens out, largely flattens out, which means that at this point, you unconsciously have realized that you don't need more information. You already know everything that you need to know. Right? And this happens here in less than 2 seconds. Right? So by repeating this with 500 people, with tons of objects, and so on and so forth, this can be a measure of image complexity, this entropy, this profile. Because simple images, this happens earlier, and for more complex images, this moves to the right. But there's a second order complexity here, which is this jagged profile in the curve, which we are thinking is representing my perceptual style. Because all these jagged movements are like upshots and downshots in entropy, which means I need to explore more. No, I need to explore it. No, I need to explore more. Sometimes they are deeper than in this case. They go like this and start doing something like this and then go flat. One thing that we think as well is that this measures your span of attention. So if you keep, for instance, imagine that you are doing an experiment, where's Waldo? ¿Dónde está Wally in Spanish, right? Sometimes you give up. You simply give up. But your entropy is going like this. Refresh, room, refresh, room, and then there will be back. You can take it anymore. So this is extremely interesting for us because it can be applied to anything. It's a measure that can be applied to pots, landscapes, buildings, squares, humans, whatever. Felipe.
It's not put from the position of the eye fixation. Not from the information extracted.
No, the position, just eye position, right? Yeah, you've been the image where it is, and so yeah. I imagine that I didn't have to explain that. So yeah, perfect. So you can start first order, second order, but you can extract also entropy from the image itself. and things like that, and combine also. Right. Felipe, you finish.
Okay. Well, quickly. What Luis has just said about entropy is one of the things that we are already just now starting to do and to realize. But to finish the seminar and to also simplify why we are studying not only objects, but archaeological, that means all ancient objects, we will come to some of the things that we did already a few years ago. And the first very idea was to take together examples, archaeological examples of, in that case, pots from different sorts of societies. In that case, they belong, they cover 4,000 years of history, from 4,000 BC to year 0. And in that case, we choose 5 different styles that each of them was related to totally different kinds of societies. In a very simple way, I can tell you that these belong to simple peasant communities, what still are much more organized at the community level, at the family level. This is also the same, but they become bigger and then a bit much more complex. This is important because this is a moment in European prehistory, in European history, when warriors and warriority start to be really important, even as an economic factor. After that, they start, ancient people start in Europe to create much more ranked, complicated societies, including finally state-organized societies. This is exactly the social background that is beside this choosing of sampling. Well, what we do, and we're still doing, is to analyze them by eye tracking, presenting as this, presenting them to different subjects, and then measuring in different ways their saccades, their fixations, and so on. Well, very simply, what we found is that each of these pots was characterized by a total different pattern of orientation of the saccades that distinguish each of them from the other. Overall, there are 2 main groups, this, the second and the third. That means that these pots were mainly seen with horizontal saccades, with horizontal eye movements, while later on appears vertical saccades that then becomes the usual thing. Well, these results allow us to define what at that point we call, and still we call, vertical index, an index to express the interaction, the relationship between the orientation of the different saccades, the relationship between the angles of the different saccades, including horizontal, diagonal, or totally vertical saccades. Well, this is, in that case, an expression of the vertical index in 3 different examples. Thank you. In 3 different examples. And then, this is useful for, and another interesting thing was to realize that the vertical index doesn't depend on gender difference. Males and females react in the same way. Also, we realized that it didn't depend on age. Different group of people belonging from 18 to 70 years old responds that way. And even more important, the vertical index was not so much related to the level of training, to the expertise of particular groups. In that case, we take together people that have no idea about archaeological materials, together with potteries, ceramists, people that have no idea about history, archaeology, or archaeological materials, but they have a real idea about how making pots. Then we took archaeologists, what of course know a lot, and all of them knew everything almost about these pots. And finally, we took a group of people that know everything about the project, including what hypothesis we wanted to check in. And this is important because I always say, and it's not only a joke, that some of the people participating in the experiment said to us, come on, I know, I am aware about the working hypothesis you want to test. So I am going to look at the pieces in a totally different way that you are expecting. Well, they never did. The real thing is that at the end, the fourth group, not connected to the level of expertise, react more or less the same way. Well, quickly, we repeat this experiment now, some years later, with different people, with different equipment, with different technicians. And the results were again the same. Well, we changed experiments in many different ways. Moreover, we also start changing the sampling and looking for samplings of pottery from other regions of Europe, other regions of the world. And generally speaking, let me go quickly to this. I will jump this. Generally speaking, at the end, what we are still looking about is that, this is a mix of Spanish and English, I think. Well, we have to do something about that. Finally, we are now checking is that still vertical index in a way is very much connected to what you could call the index of social complexity in this society. So less is the social complexity, so more horizontal is the way we look at the materials that this society did. While so much complicated is a society, more vertical is the way we look at the materials done by this society. Why this happens? Well, this is a matter for active inference, because even including, accepting, as we do, active inference as a way to try to explain how it's functioning the cognitive process, the real matter is to answer the real question to be answered is this: how active inference connect to social complexity? Perhaps there are ways to answer that question. Well, what you could answer? Well, I could answer that.
No. I was trying to avoid
our big question is how active inference connects to, in what way, with social complexity. Or
active inference means that you are looking at things in a way that resembles your internal model of the world. Your internal model of the world has been built up using your interactions with material and with society. So it's the mediator, trying to explain society.
And a simple way to present this here would be to say, depending on the complexity of the society, the complexity of the world we build is more or less. So much complicated is a society, so much complicated is also the world we build. And then the impact of this world in our inner model is totally different. This is, by now, the main hypothesis that we are trying to attack and to answer with different techniques and different methodologies and many other things. There are many other things to tell, but it's time already to finish. And please.
Thank you very much. Well, is any question or comment? Yes.
Hola. Hi. Yeah, can I go for it? Okay. Okay. That's where I wanted to go, actually, to the body. I was wondering what was the role of the body and actually of the side of the mind or the brain from within the body. That's to say the interaction between the bodily organs, and exactly, interoception. For instance, I was thinking of two studies I did some time ago in which actually with Marcos that just left, we show that bodily affordances that you have with the landscape that is surrounding you are actually modulated by the trust that you have on your body, meaning that you live in a landscape in which actually you think about action possibilities regarding how much you trust your body. Whether I think that I can go up, that becomes a possibility, but I need to have some knowledge about my body. So I wonder whether you are finding something related to that in that context, because I guess that different countries, continents, and so forth, they have a different idea of what their body is and how they can interact with the environment. And the second is again about interoception, in which, just for curiosity, like a couple of years ago, we showed that saccades and fixations are also modulated by the cardiac cycle, for instance. And now we have some preliminary data with respiration, in which we find that in certain phases of your bodily cycles actually induce less noise to the brain and are more stable in a way, is where people try to fixate and get the information to actually be able to predict better. So that's two things. Maybe with the quantity of sensor that you are using, you are able to record these sort of things. Okay.
That's the but that is it. With the movement tracking, is the relation of your body towards the material. Now with Felipe was smart enough to buy a blowgun Cerbatana, and we know the way they are built. We know the way they are used. We have some videos, and we want to study exactly that, the relationship with the Cerbatana, which is personal. It's a very personal item to the person using it. And it has peculiarities like the aim point is not at the end of the Cerbatana, is some way is towards the end, but some way in the middle. And there are many things unanswered questions that I'm sure have to do with the embodiment of your cognition, the way the materiality relates to your body, and the interoception as well. The same thing with the emotivity is what we are trying to look for. Changes in entropy and so on and so forth related to the cardiac cycle, respiration, all these things. Yeah.
Sure. Emilio? If there is not another urgent question, people might stay here if you want to talk with them because they are here.
You have shown us how this verticality index depends on the complexity of the society building the object. Have you already done experiments trying to induce to the complexity of the society in which the subject lives? So have you tried this with different subjects from different societies to see if there is also this verticality or not, or what is interaction between the two types of complexity of societies?
Not really, not yet. But yeah, but this is something that we plan to do, because actually the embedment in verticality stimulus is very important for our societies. You have the impression of being in a city, for instance, as New York, but not only. You go around and you go to church or to political events or whatever, always a vertical placement of things, of agents taking part on this event becomes extremely meaningful. So meaningful that we can understand part of the meaning about what is going on, who is the leader or who is in commanding position or whatever, just looking at the spatial interactions, the spatial relationships, and overall the vertical relationships. So this is something that we will plan to do. You must realize that a Synergy Grant project is a 6-year project. We are just ending the 2nd year of the project. The first year was most of it to develop and to prepare the equipment, the team, and the techniques. In the 2nd year, we have done a huge effort on experimental analysis, and we have completed already almost 30 different experiments involving more than 550 experimental subjects already. From now, our main focus, while still doing a lot of experimental work, will be to make deep analysis and then publications and other things with this.
Well, okay. Thank you again. Thank you very much.
Sorry, let me just quickly add one thing, very quickly, because I hope that you have already a good idea about why using materiality, why using objects. And the answer, the simple answer, I hope you already got it, is that because we humans are embedding a material world, and then objects are sending us a lot of stimulus and so on, and that way affecting our inner models. But perhaps it's not very clear to you yet why using archaeological objects, why using anthropology, or why using ethnography or history of art. And the simple answer to that is also very clear. It is because archaeology and anthropology allows us to incorporate completely different sort of societies, completely different sort of world views, other experience of the worlds done by other humans that, generally speaking, have been abandoned, have been almost hidden by actually modern research and so on. And this is archaeology and anthropology are bringing the sense of historical depth and social embedment to a project like this. That's all.
Okay, thank you very much.